Hi, welcome to Chapter 4, Section 5. So there's our mistake that always has to happen. And the subjects being covered in this section are isosceles and equilateral triangles. So the first thing you have to learn is the names for the parts of an isosceles triangle. So isosceles triangle has two congruent sides, which we already know. And so the two congruent sides, we call those the legs of the triangle. The base of the triangle is the non-congruent side. The vertex angle is the angle included by the two congruent sides. And then the base angles are the angles that include the base. You could also say that the base angles are opposite the congruent side. So that's another vocab description you can use. First theorem in the section is the isosceles triangle theorem. It says that if two sides of one triangle are congruent, then the angles opposite those sides are congruent. Again, when you're using this in a proof, you're welcome to just call it the isosceles triangle theorem. But also, if you want to, you can draw a picture for this. And what your picture would look like to use this reason would be you'd start off with a triangle with two equal sides leads to a triangle with two equal sides and two congruent angles. Okay? Don't notice that the theorem starts with the sides being congruent, okay? And that's going to become important in a second. Now, I also went through the proof of this theorem. You'll notice this line is dotted because it was added into the picture of our isosceles triangle. So again, take a moment if you can, read through this proof. And again, what we end up proving is that angle B turns out to be equal to angle C. Okay, so keep that in mind as we move through, and we're moving on to page 2. Okay, on page 2 we have the converse of the isosceles triangle theorem, and again you're welcome to just call it by its name, the converse of the isosceles triangle theorem. And what it says, if I know that two angles of one triangle are congruent, then the sides opposite those angles are also congruent, okay? So if you take a moment, you can read through the proof. And again, we had to add in this extra line in order to create the proof. So you can, in proofs that we're going to complete, you can either choose to name the converse of the isosceles triangle theorem, or you can draw a picture. So the picture would be, you start off knowing the two angles are equal, which leads to a triangle where not only are two angles equal, but two sides are equal. Okay, down at the bottom, we have another theorem. It says, if a line bisects the vertex angle of an isosceles triangle, the line is also the perpendicular bisector of the base. So, if I had a picture of an isosceles triangle, and I know that the bisector of the vertex angle would be up here, that bisector of the vertex angle, let's get some letters out here. So what this is telling you is triangle ABC is isosceles. It's also telling you that BD bisects angle ABC. Okay, so if all that happens, two hypotheses, then our conclusion will be that segment BD is the perpendicular bisector of segment AC. Okay, so that theorem is actually going to become important. Now, unfortunately, there is no cute name for it, so you are going to have to write it out. Of course, you're welcome to use angle symbols and BIS for bisect and ISO for isosceles, etc. So abbreviate as you need to. Okay, at the bottom of the page, we have a definition for you, and that's a corollary. And a corollary is merely a theorem that's easily proven from using other theorems. I consider corollaries kind of like baby theorems. They're not that important by themselves, but they use an important theorem, maybe adding 2 more steps to create it. Okay, so that being said, we're going to move on to page 3 where we have some new corollaries to learn. Okay, here on page 3, we have 2 corollaries. If a triangle is equilateral, then the triangle is equiangular. Second corollary is the converse of the first one. If a triangle is equilateral, or equiangular, pardon me, then the triangle is equilateral. And then the last one is going to be one that I added in, so you should take a second and write that down. If a triangle is equilateral, then each of the interior angles measures 60 degrees. Now, you should also make a note while we're here that all 3 of these corollaries are based upon anybody got any ideas? Well, if you guessed it, because we're talking about the measures of the angles in a triangle, they are based upon the triangle angle sum theorem. Alrighty, so keep that in mind. And, well, actually, I take it back. This last one's based upon the triangle angle sum theorem. These 2 are based upon, that's right, isotriangle theorem, and our new friend, converse of isotriangle theorem. Okay, so change this to this corollary. Sorry about that. Oh, let's make this sentence good. This corollary is based on triangle angle sum theorem. Okay, so we are set to move on to page 4. Okay, we're here on page 4 of the chapter 4, section 5 packet, and we can see that we're going to be doing some proofs. Go figure. So what I've written down the given, and of course you should mark your picture. So we read it. It says CA is congruent to AE. Oops, I've used double booked some letters here. And it also says angle AEC is congruent to angle ADB. And we're going to have to change some letters in this picture to make things work for us. AC is equal to AE. Hold that thought. I'm going to fix this and we'll be right back. Okay, so here we are, and so many things have changed. So in your picture, go ahead and take this point on the far right and make it B. In your givens, change it to be CA is congruent to AB. You don't need to change the second given. I was busy fussing around with it, but you do need to change your prove statement to prove that angle CAE was congruent to angle BAD, which is you're trying to prove these 2 angles up here are congruent to each other. So what you're going to do is you are going to mark your picture, which we didn't finish doing, AEC congruent to ADB. Now, we then look at your givens and you ask, what does that given do for me? So I have this big triangle. It has two sides equal. That's the first given. Anytime a triangle has two sides equal, the angles opposite those sides are also congruent. That would mean to us that I now know this angle C is congruent to this angle B, and of course, I want to say it in my proof. My reason would be, okay, so when you start with the sides equal, and then you say the angles are equal, that's the isosceles triangle theorem. Okay, so I've added those marks to the picture, and now if you look at the markings you have on your triangles, you can see that triangle ACE is congruent to triangle ABD. And your reason would be angle, angle, side. Notice two pairs of angles congruent to two pairs of angles. The sides not included, so we want to use angle, angle, side. Now, once the triangles are congruent, of course, our new best friend, all of their parts are congruent, and so triangle CAE, or pardon me, angle CAE would be congruent to angle BAD, and your reason would be C, PC, TC. Okay, we're going to pause for a second while I prep the second proof. Okay, so we're looking at the second proof on page 4. And what we can see here is that we've been given angle A is congruent to angle B. We've also been given that angle ACD is congruent to angle BCE. We're being asked to prove that triangle DCE is isosceles. And again, being isosceles means I want that triangle to have two congruent sides. So we need to make that happen. At this point, again, you look at your givens and ask yourself, what does that given do for me? So if two angles within a single triangle are congruent, the sides opposite them are congruent. So if we look, angle A and angle B are both part of triangle ABC. So the sides opposite them must be congruent, and that would be segment BC and segment AC. So again, mark it, say it in your picture. And that will lead to, and your reason this time, you started with the angles being equal, went to the sides being equal. That's the converse of the isosceles triangle theorem. When you start with the angles, it's the converse. Okay, now if you look at the markings on your picture, I have enough to say that triangle ACD is congruent to, be careful with your markings, BCE, and the reason would be angle, side, angle. Okay, now that those two triangles are congruent, their parts are congruent. Well, which parts do I need to accomplish my goal of the triangle being isosceles? I need for, go ahead, think about it for a second. Exactly, segment DC to be congruent to segment CE. We're going to run out of time possibly. At that point, your reason is CPCTC. Last step, of course, is the last step of the proof, and your reason will be definition of isosceles triangle. All right, folks, stay classy.